in terms of getting
speed dating, technical speed dating.
Yeah, speed dating, right?
Yeah, to some extent, yeah. And it's also made available through a sponsorship from Galliford Try. So thank you for that. That is really important that we also get the funds to get the experts on board here, that we can really be enlightened and have that as a good preparation for today. We're still getting people on board here, so it's very good. We will just give it a minute or two more in terms of us starting up. I have no idea how many we are, Pernille. Do you? So we have Pernille helping me here in the studio. Now we have Uffe also. Uffe Sovnstrup, welcome from the University of Aarhus. Is also with us now, I saw. Yeah, we're still missing 5, I hear. So still one more minute, but welcome to this extended water talk. As I said before, it's normally 1 hour. We've extended it to 1.5 hours, and it will probably feel too short anyway, because there's so many things that we need to cover here today. And I also have to say that this water talk has only been made possible through a sponsorship, Galliford Try. So thank you for that. Still 1 more minute, and this is about coffee time or tea time.
Yeah, quick moment to be able to grab a quick coffee. Yeah.
Make it if you can reach coffee or tea in a minute, which is actually about now. So we will start sharing the presentation and get on with it. Yeah. So this water talk is about removal, and I'll also get to some of the details a little bit later. And it's only been made possible through this sponsorship from Galliford Try, just so that we get an overview of who is attending. Yeah. Then this is the list of those that have signed up, and it goes further actually to here. And if the companies have a solution which is being presented today, and if there's more than one person present from the company, we've made them bold in terms of Galliford Try knows who to contact. And the other way around, it will be Paul Dorrington from Galliford Try, who will be the primary contact in their end. We'll just go to the agenda here very shortly. So by me and us from Danish Export Association, then we'll have a welcome from Galliford Try to just briefly touch upon who Galliford Try is, but also why they actually are interested in Danish suppliers and know-how for the removal and destruction of PFAS. Then after a short welcome there, then 10 minutes to the hour, Jonathan Guld Christensen at the Danish Technology Institute will actually present what is the problem and the status on the various Danish solutions that we do have. And then there will be about 20 minutes, and some of the suppliers of solutions will actually be mentioned in that material. There is also one example of a PFAS removal train, which will be reused through the presentation. Then we have from DHI, we will have a presentation of the next generation digital tools to support the removal of micropollutants in wastewater. And there will also be a brief introduction to the legislation, primarily the European legislation ongoing right now, so that we get a status here as well. Then I will try in 15 minutes to present 10 companies' various solutions. And this will be hard, not for me to open up, and it will be very, very brief. And that was back to the introduction where we said this is more like a matchmaking, getting to know, getting an overview, who to contact, and so forth. This will not in any way, shape, or form be a detailed presentation of the solutions that you might offer. Then 20 minutes to the hour, we'll have a Q&A session, and I'll come back to how we would like to engage here. And I have to say that the preference will be for the utilities and questions from Galliford Try more than the other way around, because we only have 15 minutes that I'm sure will feel very short. Then we'll 5 minutes to the hour wrap up and talk about potential next steps, also with Galliford Try. And then we'll end the water talk, and I promise at the hour, because many of you will have other meetings to attend to. So that is the format of today and the water talk. There are a few guidelines here. So we've started recording, which you probably noticed. And if you don't want to be recorded, you should opt out now. Then if you do have questions, we would actually prefer that you wait and you put it in the chat where we'll try to cover it. If you hear something where you say, well, this was not exactly correct or something else, you are of course allowed to raise your arm to have that question answered straight away. Regarding timekeeping, I've been through that as well. Then there's a little bit on the problem in terms of how this all started out in Denmark. And that actually started out in 2022 with the measurements of PFAS in fire rehearsal areas. And a lot of those measurements were done by the company NIOS, who was also present here today, but there was also other companies involved. And then afterwards, it was actually measured in the milk of the cows that were grazing at these fields. And then we found out we had a big problem because it actually ends up inside humans. Soon after, it was found in seawater foam. And we found out that we had a bigger problem than we thought. So being a pretty wealthy nation and basing our water reservoirs on groundwater, we are very susceptible to substances and micropollutants like PFAS. We have a huge shoreline for a very small country, and hence we had to do something about this. Today, we'll focus on those solutions that are actually being implemented right now by Danish Technological Institute, but also looking ahead by DHI in terms of what is to come, including other micropollutants and legislation. Unfortunately, PFAS is found everywhere we test for it, and it has gotten in the water, and especially those countries that are using surface water for drinking, it's an even bigger problem. And a not so fun fact is that one of our service partners, Bluefield Research, has just revealed that PFAS is found, and other forever chemicals are found in 95% of 23 tested beers in the EU. So we have a big job in front of us, both in terms of the EPCs, the utilities, the technology suppliers, and the advisory companies. So which will just be starting up today to trying to bridge these Danish experience and bring it to the British Isles. So that was a short introduction here from my side in terms of why we are here today. And now I would like to introduce the people present from Galliford Try. So Kay Denham, who is the engineering director from Galliford Try's engineering division. She's a chartered engineer and a fellow of the Institute of Mechanical Engineers, bringing over 20 years of experience in the water and wastewater industry. She also holds a Bachelor in Engineering with honors in Mechanical Engineering and Master of Science in Water and Wastewater from the Cranfield University. Recently, Kay was named a finalist in the Inspirational Leader category at the 2025 Construction News Inspiring Women in Construction and Engineering Awards. Welcome, Kay. We also have here with us, and are so fortunate to have Chris Paul with us, who leads and drives the process of engineering design across Galliford Try's UK-wide team. As a process discipline, manager and holds over 20 years of experience delivering major projects in drinking water, wastewater, sludge treatment, and mineral processing. He holds a master's degree at the University of Cranfield, where his thesis is actually focusing on PFAS and the methods for its removal, and additionally holds a Master of Engineering in Chemical Engineering from the University of Sheffield. Welcome, Chris. Then one of today's speakers from Galliford Try is Stuart Bearfield, and he is the Director of Asset Optimization and is a chartered chemical engineer with over 33 years of experience across the municipal water and wastewater, nuclear decommissioning, and the industrial sector. He has led and developed process design teams within both contracting and consulting organizations and brings extensive expertise in client relationship management, feasibility assessments, and front-end engineering design. Stuart's broad experience spans technical and commercial risk evaluation, CAPEX, OPEX, assessments, construction commissioning, and plant operations, making him a highly versatile and respected professional within this industry, and he is amongst one of today's speakers. Welcome, Stuart. Then we have Paul Dorrington, who is a technical manager within Galliford Try's environmental business, leading the development of innovative and compliant engineering solutions for the water sector, with over 20 years of experience spanning design, delivery, and operational leadership, with a specialism in control and automation. And currently, you are tasked with developing Galliford Try's PFAS portfolio to bring innovation and collaboration to our UK water industry client. And you are also amongst the speakers of today. And Paul Dorrington will also be your direct contact for those that are technology or solution suppliers afterwards. And with this quite extensive introduction, I hope that you will take it away, Paul. And Stuart, welcome.
Thank you, Klaus.
Right. Good afternoon, everyone. So, as Klaus said, my name is Paul Dorrington, Technical Manager for Solutions Development within Galliford Try. I'll just check you can hear me. Yes, you can.
Yeah.
I'd like to start by thanking Klaus, Lixia, and Alpinil for their hard work in making today's event possible. A big thank you also to Jonathan and Fabio for generously giving up their time and sharing their expertise. Also, a massive thank you to my colleagues who have also joined the call from Galliford Try, and of course a special thank you to everyone who else who's joining and watching. Galliford Try, our core capabilities. Our teams deliver a full spectrum of water infrastructure, and with this, we've got these sort of separate business units. So, sort of starting from the top, we have asset creation, so design and construction of water and wastewater infrastructure, covering a full project life cycle, and with our expertise spanning sort of water, wastewater treatment plants, sort of new build upgrades, pumping stations, pipelines, and networks, and non-infrastructure services. Then we move onto engineering services, a full service engineering and advisory capability that supports clients from early engagement through to delivery and handover, with our key strengths including early contractor involvement, multidisciplinary design, sort of civil, ICA, electrical, and so on, program and delivery planning, sort of construction methodologies and sequencing and things, and regulatory and technical assurance as well. But essentially, our engineering services ensures efficient, resilient, and operationally effective solutions before a spade even hits the ground. Next, this is actually Stuart's sort of business unit. This is asset optimization. So this is improving the performance, reliability, and whole life value of existing assets through things like digital monitoring and diagnostics, predictive maintenance, process performance reviews, and operational optimization, essentially. Then down the bottom, you do notice some of our other brands. So we have a products part of the business. So we've got Lintott Control Systems and Hambaker Engineering. So essentially, between the two businesses, they manufacture motor control centers, PLC control systems, automation and SCADA. There's chemical dosing equipment, so sort of coagulation, disinfectants, pH, etc., etc. They also manufacture UV treatment units, and then when in Ham Baker specifically, we manufacture sort of inlet screens and distributor arms, pen stocks and flow control. Then moving on to sort of the fabrications part of the business, specialist fabrication services supporting complex sort of water infrastructure projects, with custom access platforms and walkways, supports, and they also do pipework fabrication. And then finally on that list, we have asset maintenance. So comprehensive operational support and minor works, sort of to keep assets safe, compliant and reliable. And so they do this by sort of reactive and planned maintenance, minor works and upgrades. They also cover off sort of emergency interventions, call outs and things, and then also provide ongoing operational support of clients' assets. So to ensure the business delivers all of these capabilities to the highest of standard, we operate 19 strategically based offices and manufacturing facilities, spanning right from the southwest, where I'm based, right up to the far north of Scotland. So moving on to the next slide. So major frameworks. Galliford Try's environmental division operates under a series of key frameworks that enable us to deliver sustainable, high-quality solutions across the UK. These frameworks span water and wastewater infrastructure, environmental engineering and asset optimization. Our approach is obviously built on collaboration, innovation and strict compliance with industry standards. Through these frameworks, we work with major clients such as Thames Water, Severn Trent Water and Affinity Water, delivering projects that strengthen resilience and sustainability. On the screen is just the main sort of the larger frameworks, but actually across the UK, we're proud to be part of 55 frameworks in total. When during the presentations and when you hear some of us talk today, you might hear us mention AMPs. So I'll just quickly explain what an AMP is. An AMP stands for an asset management plan, and that's a 5-year procurement cycle used in the water industry. So we've just entered into AMP8, which runs through to 2030, and it represents a huge opportunity for innovation and collaboration across the sector. So in a nutshell, that's sort of me wrapping up the overview of Galliford Try's environment division. And at this point, I'd like to hand over to my other presenting colleague, Stuart Bearfield, who will talk specifically about PFAS within the UK.
Yeah, do you want to jump on the slide and move that one forward then, please,
Yep.
Paul? Yeah, it's just really just to put a bit of context to why we're here, So obviously things are starting in the current investment period in terms of we got the guide, got the guidelines really coming in from the GWI, based on a sort of tier structure for sort of to initiate actions really. But looking further afield, Denmark, this is one of the reasons, the reason we're here is because effectively Denmark have been doing this for longer, and they've also got some very stringent standards, which are actually an exceedance of the European standards. So really, I've been to recent conferences. There's been the British Water event recently in Warwick, the Institute of Water. Some of the messages we're getting all the time across the industry is people collaborating, innovation. And I thought this is a fantastic opportunity to reach out to Klaus and the Danish market really to understand what they're doing and seeing what we can learn really. Cheers, Paul. That's it. Thanks.
No worries. That's us, Klaus. Thank you.
Yeah, thank you for the welcome here and the introductions we have. We'll just take back control in terms of the presentation. Should be a little slow today. So part of the introductions today to the topic, we are so fortunate we had Jonathan Gull Christensen from the Danish Technological Institute, who is a consultant within wastewater and residues from the wastewater. He holds a Master of Engineering in Biotechnical and Chemical Engineering, and he has the last couple of years developed into one of the most knowledgeable experts that we do hold in Denmark within the removal and destruction of PFAS from water, and also is behind the idea and concept of the PFAS treatment train, which we will also see in action today. So, Jonathan, please take it away. So while we're waiting,
yeah, I should have unmuted beforehand, but thank you so much, Klaus. I'll just get my slides up here on screen now.
And I have to say also for everybody, which I missed to say in the beginning, so the slides you'll see will be shared completely afterwards. So you don't have to take pictures and anything else. There's nothing hidden here.
Yes. Perfect. Well, thank you so much for the kind introduction, Klaus, and thank you so much to you and to Galifort for making this arrangement and making this talk happen. As Klaus said, I'm Jonathan Gull Christensen. I'm a consultant at Danish Technological Institute here in Denmark, where much of my work revolves around environmental contaminants, emerging contaminants, which PFAS, of course, is of special interest. And that's why I'm also here to talk about the PFAS problem and some status on Danish solutions today. But I'd like to just start out very briefly to introduce Danish Technological Institute and what we do in advancing water treatment solutions. So what we do as a company is that we have a goal to support primarily Danish companies, but also European and international companies in technology development and implementation of sustainable technologies in general. And my focus is then specifically on water and wastewater treatment. And what we do here is that we try to bridge the gap between universities and then commercial applications of newest research and technology development. And then we also do testing and development in our own labs, where we do tests and development of new types of technology, and we also do validation of existing technologies. And then we also try to provide regulatory support whenever new regulation comes out in the EU or Denmark, in order for people to accommodate the new regulation. So that's kind of our role in the water business, and more specifically related to PFAS. But what I'll be going through today will be to kind of introduce the problem. I'll only very briefly touch upon the problem of PFAS because I think we're all aware of that. Then I'll delve into some of the treatment technologies, and then I'll have two cases here from Denmark. Of course, there are many more projects going on, so I had to select a few now that I only have 20 minutes. And then I'll very briefly touch upon also destruction technologies, and then I'll summarize in the end. But I actually like to start up with this slide because I think it pretty well summarizes how PFAS is spreading into the environment and how it has now become kind of like a cycle in our environment, just as we've come to understand from our teaching that, for instance, carbon has a cycle, or water has a cycle. Now we also see that PFAS is actually circulating around in the environment. And I think I'll just bring up a pen here. So, I mean, how it stands today is that we have PFAS everywhere in our environment. It has been there in production for many years by now. So we see it in our groundwater, freshwater, marine environment, and everywhere, really. And this is, of course, the PFAS that's already there, but we're also still sending out further PFAS into circulation. And this primarily comes from different point sources. Those could be waste management sites or different landfill sites where you have leaching out into wastewater treatment plants. And the wastewater treatment plants in Denmark are really good at removing different organic matters, also nitrogen and phosphorus. They're really not capable of removing environmental contaminants in the same way, such as PFAS. So that's why actually these pollutants will go through the wastewater treatment plants and then end up in the environment afterwards. And of course, also different industries that either produce PFAS molecules or use them in some kind of production, which means that there will be some PFAS then transmitted further on through the wastewater. And then we, of course, have heard about many different hotspots of PFAS. Those could be firefighting schools, where we have firefighting foams with PFAS in them. And we also have many different airfield sites or different military sites where PFAS have been used throughout the years, and where we still see it in the ground and then leaching into the environment. Yes. So I think this pretty much summarizes also then how it ends up back in our private households through the water that we drink, through the food that we eat. In Denmark, by far the largest source of PFAS in human consumption is the food that we eat. And this comes from the water that we add to our fields, the sludge that we use for fertilization, and also some of the pesticides that we add to the fields, which do also still contain some PFAS molecules. But that's a whole different story. I'll continue on to the PFAS removal, because that's what we're here for today. I like to divide it into two, because whenever I say PFAS removal, it has to do with both removal from the wastewater stream or from the environment, and then also a destruction process afterwards. So it's kind of a two-sided or two-stage process. Because if we only remove the PFAS, and then put it in another landfill site where it can then leach out again, then we haven't really got to the core of the problem. So we have to also destroy and actually remove PFAS from this circulation in order to really get to the core of the problem. And that means, of course, complete defluorination of the fluorinated carbon compounds, which are the PFAS molecules that we are focusing on today. When talking about removal more specifically, we can actually divide it into a more centralized or decentralized approach. So a centralized approach would be to take care of the problem at the centralized municipal wastewater treatment plants, where we have most of the wastewater coming through, and then we will be able to there actually implement different steps in order to accommodate the PFAS problem. Or you could do it more decentralized, where you would focus on different point sources where you have the more concentrated PFAS streams and remove it there before it's mixed with the rest of the municipal wastewater. And of course, there are pros and cons to both of those approaches, and probably both will be in use in the years going forward. But if you do have a centralized approach, of course, as with everything, you'll have the economy of scale. Also, more specifically related to PFAS, there will be a lower organic matter contamination after the water's gone through the municipal wastewater treatment plants. And this has a lot to say when we're talking about adsorption technologies for PFAS removal afterwards, since this then lowers the amount of other co-contaminants. But of course, if we go for a centralized approach, then we'll also dilute our contaminants before treatment, and we'll have much larger volumes to treat. So this will be some of the cons of a centralized approach. If you are to go for a decentralized removal approach, then you'll go directly to the source where you have high PFAS concentrations. You'll have minimal dilution of your contaminant. So you'll be able to remove bulk of the PFAS before you actually mix it in with remaining municipal wastewater with lower PFAS concentration. So you'll have lower volumes to treat. But of course, you won't have the same economy of scale. And you will also definitely have a higher water variability. So it will not be as predictive as of to what kind of wastewater will be coming into your plant throughout the year, or depending on the different cases. And you'll definitely also have many more co-contaminants than when mixed with the municipal wastewater. So going over some of the treatment technologies and how to remove PFAS from liquid waste streams. So the established solution, you might have heard this before, but then I'll just say it again, that adsorption is the established solution to PFAS removal. And this involves different types of adsorption materials. It involves different types of activated carbon with high surface areas, which are very good at absorbing all kinds of organic molecules, including PFAS molecules, but mostly it will be tailored for longer chain PFAS molecules and not so much the shorter chain PFAS molecules, which are more mobile in the water stream and won't attach as much to the activated carbon. And then you also have ion exchange resins, which are, you could say, more tailored towards targeting PFAS in general and also shorter chain PFAS molecules compared to activated carbon. Those are also more expensive to use, so it will also be kind of a balance between what expenses will be there and what type of wastewater will you have coming in, because the wastewater should be as free of other co-contaminants as possible before you then send it through your ion exchange resin. Then, as Klaus mentioned, I don't think I invented the treatment train. It's just a word that we use for a combination of different technologies for any particular treatment solution. But it's a good way to look at the PFAS problem, because often you'll have to have a sequence of different treatment technologies in order to achieve the removal rates of PFAS that we would like. For instance, if we were to go for groundwater treatment, as we do here in Denmark, mostly we can make do with very little to clean our groundwater. But actually, Grundfos, that I know is present here today, have set up at least two places that I know, ion exchange resin filters, in order to remove PFAS and provide clean drinking water for water utilities here in Denmark, where contamination has been found, and with great success. And then if we were to have some more contaminated water, then that could, for instance, be drainage from firefighting areas, where you would have particles, other co-contaminants that you would then first remove in a filtration unit, and then afterwards send through an adsorption column or two. And then if we were to go for even higher pollution waters, that could, for instance, be different types of industrial wastewaters or leachate from landfill sites, which is very complex water with lots of organic material, then you would definitely need further pre-treatment steps in order to remove most organic material, co-contaminants, and then in the end, that water would then be able to be sent through an ion exchange resin in order to remove the remaining PFAS. And then, of course, you'll have some sludge produced, which would have to be destroyed in a destruction technology. But adsorption is not the only technology that we use to remove PFAS from wastewater. There are also other technologies being implemented. One of them is to use coagulation and flocculation technologies. This is a very common technology within wastewater treatment that you use in many instances to remove organic matter and other matter from wastewater. What you do here is you add metal salts, you add polymers in order to make particles clump together, and then you'll be able to remove them from suspension. And then you would have a sludge, which you can then destroy, and then you would have your water fraction, which would be free or at least almost free of the molecules you would like to remove. And this technology can also be used with special PFAS chemicals, no, not PFAS containing chemicals, but chemicals which would actually help adsorb and keep PFAS bound to the sludge phase, so it can actually be removed using a combination of coagulation and flocculation chemistry. So that's one approach, which is outside of adsorption. Then another one is to use the surface active, you could say, properties of PFAS molecules. So that would be via either foam or bubble fractionation, where you send air through a column of contaminated wastewater. And in this way, you will have PFAS accumulating at the interface between water and air. And it will then accumulate in the foam that you can then collect. And this collapsed foam can then actually be sent through this process repeatedly in order to produce a very PFAS heavy concentrate, which could then be destroyed afterwards. And then you'd have your effluent free of PFAS if you're dealing with longer chain PFASs, but if you're dealing with shorter chain PFASs, then probably you'll still have to do some additional steps in order to get rid of the last short chain PFAS molecules. And this is kind of the same when we're talking about coagulation technology, that we'll be able to remove most of the PFAS, but there will probably still be some of the shorter chain PFAS molecules present. But like before I sum up, I'll just like to briefly go to case studies from Denmark, because I think it's interesting to actually go into concrete cases. One of them, I think, Klaus, you already mentioned this briefly. Actually, this is on sea land on the eastern part of Denmark, where there is a firefighting station. And this has been actually come to be known as the ground zero for PFAS contamination in Denmark. So this was where in 2021 that people found out that PFAS was leaching out from this firefighting training area into the nearby meadow. That contaminated cows that were grazing at the meadow. It ended up in their meat. And then when people ate that meat, they had elevated PFAS levels in their blood. And that was why people actually got to become concerned of PFAS contamination in Denmark. And then it has just, I guess, snowballed from there, really. But with this ground zero, and we have many firefighting schools like this in Denmark, and I guess you probably have as well in the UK. With this in mind, actually, there were set up several PFAS treatment systems to be tested then at this site in Denmark. So it has been used as kind of like a test center where different companies have been setting up treatment systems. And today, the Danish company Ultra Aqua runs a treatment plant that collects all the drainage from this area and from the nearby meadow, and then treats it to remove PFAS so it doesn't leach further into the environment. And this is just a real-world example of a treatment train. So you can find, of course, more information on Ultra Aqua's website. But here they have a filter that takes most of the particles as they come in from the meadow. And then they use their patented bubble fractionation technology in order to remove the bulk of the PFAS. And then through a sand filter and through two adsorption columns, one with activated carbon and one with ion exchange resin. And it is where they are able to then meet the very strict guideline limits for the outlet of PFAS. So they remove from elevated levels of above 20,000 nanograms per liter down to almost at detection level limits, so well below the limits in their outlet. There's also another case from the northern part of Jutland in Hjørring, where the municipalities, so the local wastewater treatment plant, they have had exceeded PFAS limits in their sludge, most of which we use for field application to recycle nutrients in Denmark. But you can't really do this if the PFAS levels are too high in the sludge. So they did have problems with this. And that was to do with several old landfills that they identified and oil treatment companies in the area around the wastewater treatment plant. So they decided to set up actually a PFAS treatment system to handle all the PFAS contaminated streams before they were mixed in with the municipal wastewater. So kind of like a PFAS pre-treatment plant set up actually at the wastewater treatment plant, but just to take up the bulk of the PFAS before it was introduced and mixed with the rest of the wastewater. So what they do there, they go for the coagulation approach, where they add metal salts, this PFAS binding chemical and polymer, and then they're able to form those large particle flocks and remove them afterwards. The system there is provided by the Danish brand of the company ECT2, Montrose Environmental Group. And what it looks like is this. So on the left here, you would have the flocculation, the chemical addition to the wastewater. And then over here, you would have you will have all the air being introduced in this flotation plant, and then you'll have the wastewater contaminated with PFAS skimmed off at the top. And then afterwards, this sludge can then be dewatered and sent for PFAS destruction. And then you would have removed most of the PFAS in the wastewater going into the plant. they also let me show just a little bit of the data from their plant. So as you see here, this is not a 100% solution for PFAS removal. It removes the bulk of the PFAS and has been doing so since by the end of 2023. Where most of PFAS 4 and more than 70% of PFAS 22 is removed in this plant. And this has been enough to actually lower the limits of the PFAS in the sludge at the municipal wastewater treatment plant to below the limits that they have to abide to, and also for their effluent to be clean enough that they can then send it out into the recipient water afterwards. And of course, there will be differences in the short and long chain, as you see here. For instance, PFPEA will be one of the ones which are not reduced to the same extent that maybe some of the longer chain PFASs. Yes. And as I said, when you're dealing with a more decentralized approach where you actually take out the PFAS from the point sources, then you'll be able to just treat smaller volumes instead. But as I'm wrapping up, and I know I'm nearing my 20 minutes, Klaus, so yeah. I'll stick to the time. But just one slide on PFAS destruction, because as I said, this is also very important. And today, the destruction standard is that you incinerate whatever PFAS concentrate you have once it's removed from the environment or from the wastewater, and incinerate at high temperature because it requires a lot of energy to break the fluorine-carbon bonds and to completely defluorinate the PFAS molecules. But there are definitely also other solutions which are being introduced. I just put a few of them up here of Danish alternatives. There are the Danish company Accordant, which is working with supercritical water oxidation and have set up 2 plants in France operating to destroy PFAS with their oxidation technology. Then we have Ultra Aqua that I also mentioned that have the treatment plant at Korsør. They have some pilot scale vacuum UV units set up in order to destroy PFAS using their UV technology. And I've heard they had good results from testing on the water from Korsør. And then we also have different companies providing pyrolysis technology. AquaGreen is one of them. They have 2 full-scale plants operating on municipal sludge here in Denmark. And also one of the advantages of this technology is that it can help break down PFAS during the pyrolysis process. So I think that was more or less it. Just to summarize, I mean, if we are to limit PFAS exposure, we need to both remove and completely break down, destroy PFAS, and different scenarios call for different tailored solutions. We do have adsorption as an established technology that we can use for removal, but it will definitely require pairing with other types of technology in some kind of treatment train for most instances. And then we have other technologies which are also coming in and being developed and then used for different use cases for PFAS removal. And then incineration, it's a standard approach that we use today, but there are definitely many technologies being introduced, and this is also one of the very important areas to do further research in order to have good destruction technologies for PFAS. Maybe I went 2 minutes over my time, but thank you so much for listening, and then we'll have time for questions afterwards, I think.
Yeah, thank you. So thank you, Jonathan. There was also a question during your presentation. You actually answered it during a little later in one of your slides. So, and there's others I can see coming up because there's also other technologies than what we just presented, which you also. So next speaker is Fabio Polesale. I'm not sure I pronounced that correctly, Fabio. Sorry.
That's perfect. That's perfect.
Okay, good. You're the team lead for wastewater treatment at DHI in the headquarters in Denmark. You have 15 years of experience in modeling micropollutants in wastewater treatment systems, and you're also running a lot of projects on digital twins within this field, which is also very interesting. Then you have a focus on pharmaceuticals and PFAS and other conventional and advanced treatment technologies to remove PFAS, amongst other micropollutants. I know you will touch upon bisphenol A, which is also believed that could be one of the next substances. And the good thing is that some of the treatments that you've seen, will actually be the same. Even though, as mentioned before, that the order and what you select is based on the actual source. So without further ado, Fabio, please take it away from DHI.
Thank you very much, Klaus, for the kind introduction. And also I would like to take the chance of thanking you, your team, and also Galiford-Try for giving me the opportunity of presenting our work at DHI. So just to put things a bit into context, I would like to move from the physical world to the virtual world. So I will talk about digital tools and modeling tools. I would also like to zoom out a little bit. So looking at PFAS as the more general micropollutant issue, and also zooming in on wastewater treatment systems. So they're one of the, you can say, key points in the water cycle that Jonathan has previously presented, as they are key point sources for the release in the environment of PFAS and other micropollutants. So this said, a few words about DHI. So DHI stands for Danish Hydraulic Institute. We have a headquarters in Denmark, in the north of Copenhagen, and in Hørsholm, and we also have an office in Aarhus. But we actually have offices or agent representations in 5 continents. Including an office in Southampton in the UK. And what very briefly we work with, we hold strong, you can say, domain knowledge and also modeling related knowledge to tackle water related issues in various contexts in pretty much three contexts: water cities, so water quantity and water quality related issues in urban areas, marine and coastal environments, and also water-related issues on renewable energy and water resources, so groundwater, inland water systems. As I said, we provide advisory to various types of clients, technology suppliers, authorities, water utilities, governmental agencies. But we also, you can say, modeling is well rooted in our DNA, and it's part of our advisory services. But we also provide modeling software to external users, to clients, as part of our Mic powered by DHI software suite. So that allows to model water in various systems. Yes, that's very briefly. I can probably spend half an hour talking about what we do, but that's not my goal today. So, as I said, zooming out a little bit, we know that PFAS is and micropollutants in general is important, but also complex issues. We have thousands of substances being detected, measured in our in water cycle, and hundreds of them being actually detected in wastewater and sewage sludge. And it's a complicated issue due to the large numbers of substances. And we see increasing efforts to tackle the micropollutant issue at the regulatory level, at the European and Danish context. So the regulation itself, as we probably like to do things in the European Union, is also quite complicated. But looking at wastewater treatment plants, we have a recently approved revised European Wastewater Treatment Directive that actually set mandates that 12 substances are removed through what we call advanced quaternary treatment in municipal wastewater treatment plants. And removal efficiencies above 80% need to be achieved for plants above 10,000 Ps for sensitivity recipients or above 150,000 population equivalents, no matter what. This directive is enforced since 1st of January, so that's something that utilities in the European Union will have to face sooner or later. On the other hand, we can see that only 12 compounds are being regulated, and these are pharmaceuticals and benzotriazoles. But we also see increasing discussion and actually preliminary information on the Water Framework Directive that sets environmental quality standards in the recipients. This is in discussion. There's a preliminary provisional deal that sets environmental quality standards for 24 PFAS and other substances like bisphenol A. And of course, when we think about effluent discharges in recipients, these new limits will have to be fulfilled. So this is 12 compounds from the Wastewater Treatment Directive plus additional substances. And we also have a quite outdated Sewage Sludge Directive. You know, sludge is also a source of micropollutants in the environment through land application. And right now, the Sewage Sludge Directive is 40 years old, and it sets limits only to heavy metals. But as we know, PFAS is accumulating in sewage sludge quite extensively. And there is ongoing focus on setting limits for substances also in the sludge. And I'm just sharing here an example of what has been assessed at the moment. This is a report that DHI has contributed to for the Danish Environmental Protection Agency that sets recommended threshold value of 50 microgram per kilogram for the 4 key PFAS in sewage sludge. This is not a regulation, but this might end up in the regulation pretty soon. So we have a complex issue and also complex regulatory landscape that, of course, sets limits, sets actions, but also makes things complex for utilities. And how can we tackle the micropollutant challenge? Well, of course, the 2 key actions so far has been to monitor their occurrence in the water cycle and implement, where needed, advanced treatment technologies. But we have, you can say, a third action, which is to use digital tools and modeling to support these 2 other actions. And this can provide benefits. On the one hand, it can help reduce monitoring costs by doing early screening of micropollutants, so finding out which micropollutants are actually occurring or more risky in the water cycle, and so therefore reduce the costs of monitoring, which we know, and analytics, which we know is quite expensive. And on the treatment side, digital tools and modeling can help upfront identifying whether wastewater treatment plants need to be upgraded or retrofitted. And also, if this need is fulfilled, then helping technology suppliers designing and commissioning these advanced treatment steps. And yeah, so this said, I would like to present you 3 examples of how we have applied digital tools at 3 different steps. You can say in the water cycle, but also in the, you can say, life cycle of a treatment plant. And as I said, we can apply digital tools to screen compounds of potential concerns, not just in the treatment plants, but also upstream in catchments. And one example of this is a tool that we have recently actually extended as part of the VUDP. That's a water development and demonstration program in Denmark. It was a project that actually called Rainwater Quality, Regnvandsqualitet, where we had developed a tool to help utilities screening stormwater discharges. So we focus a lot on municipal industrial wastewater, but actually stormwater discharge can also bring through runoff from industrial areas, pollutants in the recipients. So this tool, and I'm showing here an example for the city of, for a catchment in the city of Esbjerg, and this tool allows to predict what's the expected concentration of 78 substances, including 4 PFAS in the recipients, in relation to stormwater discharges. And this can help the utility and the authority applying for permit. First of all, identifying which compounds can be a concern. It can help them in the application for discharge permits, and also it can help them identifying whether some treatment of the stormwater needs to be implemented to mitigate the risk. The second example I wanted to show you is how we can use models to assess the performance of currently operating wastewater treatment plants and finding out whether they actually are already performing well or are not performing well enough in the removal of micropollutants. And this is an example from a model that we have implemented using our in-house software West, where we helped a water utility understanding how is the treatment plant performing with respect to the removal of PFAS and PFOA. And what they could actually, for instance, observe was that effluent concentrations were systematically higher than influent concentrations. So there was probably some formation from precursors in the conventional treatment. But what we can also see is that the concentration in biosolids, not surprisingly, was significant, and meaning that the treatment plant, the utility might need to implement some additional treatment to mitigate, to reduce the concentration in the biosolids before they are applied on land. And finally, the third example is moving to the last step, is when the need of advanced treatment is acknowledged. How can digital tools be used to support the design and implementation of advanced treatment? And here, as Klaus has very nicely introduced, I would like to present the example of bisphenol A. We know it's not a PFAS, but it is a very similar situation as PFAS, because it is not targeted by the revised Urban Wastewater Treatment Directive, but in Denmark and soon in Europe, ideally, there will be quite stringent environmental quality standards in the recipient. And this is an example of a study that we did in a treatment plant in one of the largest treatment plants in Denmark. I'm trying to find out whether with the current conventional operation, with the conventional treatment, can remove bisphenol A to the required level set by the environmental quality standards. And the answer is no. As you can see from this picture, actually, the conventional treatment is pretty good at removing bisphenol A, more than 90%, but still not enough to achieve the EQS. And so what we used the models for is to assess what's the best setup to actually bring the concentration of bisphenol A down to the EQS limit. So thanks to our capabilities of our software, we could implement how a treatment train could look like with ozonation and activated carbon. And actually, we have compared the performance of this system, of this combined system, with ozonation alone and with activated carbon alone. And what we could see was that, based on our initial evaluation, was that the combination of these two advanced treatment technologies was the most suitable. First of all, because it brings down, that's probably you can see here from the purple line, the final effluent concentration below 10 nanograms per liter. Of course, at some point, the activated carbon gets saturated and needs to be regenerated. But also comparing with the single treatment, we could see that the combined treatment was beneficial by reducing the ozone dose and also doubling the lifetime of GAC. So you can see a need, if GAC was to be implemented in combination with ozonation, regeneration of the GAC would be required every half a year, as opposed to every 3 months.
Fabio, you had to end in 1 minute.
Yes, I'm done. That was my last slide.
Yeah.
So that's an example of how we can use digital tools to virtually, you can say, design and operate some of the treatment trains that were presented before by Jonathan. So that was it from my side, and thank you again.
Thank you. So we'll just go back to us presenting here. Thank you both to Jonathan and Fabio for your very in-depth presentations on the problem, trying to provide an overview. We do also have various individual solutions present, which we'll show in the next slide. So we have identified 17 companies who are working in this field. There's probably more, but we have identified 17, and 10 of these have either been presented already or will be presented in the following. The other 7, actually, most of them are not ready yet to share, or they have identified themselves as a sub-supplier to a system supplier, and hence do not see the relevance in them presenting. My idea and ambition was to present this as a table, which was not possible because the solutions are quite different. And I've also not provided the opportunity to the suppliers to be able to speak today, because it is salespeople, and I know they can't keep it short, because you have to trust me, I'm a former salesperson myself. So if we just move on here with the first one, that will be Grundfos. So, and there you can see, just for the introduction in terms of the PFAS train, which is relevant for most of the presentations here today, it's also shown up in the right corner what kind of solutions that they do have within this field for removing PFAS in drinking water by ion exchange, with 2 cases which you can press on and learn more, and also that what they have of total experience. That is the one company at Grundfos. The other one is Nuterra in the US, which is also going to be rebranded to Grundfos. And there they have hundreds of installations worldwide, also large scale. And the contact here is Alexander Satchikov, head of sales and service. If we just take Nuterra, again, it's the same. It's granulated activated carbon, ion exchange, and reverse osmosis, running a lot of systems and pilots, and also able to run life cycle service on them. We take the next one, NIOS, also a very important contributor here as an advisory company, doing a lot of work in terms of within different fields, where we can see different contaminants on seawater foam, waterworks, also in terms of soil. Then you also provided a lot of input to the governmental regulations, actually, in terms of enforcing the PFAS restrictions in Denmark. Also a lot of experience within PFAS destruction and evaluation of different suppliers. And this is young Max Arana-Juve, who's your contact here, if you wish to hear more. The next one is Aqua Green, who is providing pyrolysis, and the process here is also quite interesting. So the end product is biochar, which can actually be used before the carbonated activated carbon, and then it's also thermally, which I had to look up, which actually means that the system is actually able to generate all the energy. So it's energy neutral on the thermal side on itself, which is a nice feature. It's both a complete removal and also destruction of PFAS. And also they have a system running here. So what you see here is actually, this is not just research, this is not just ideas, this is actually installations and things that are in operation that you are being exposed to here, and where I think this of bridging the gap from Denmark to Britain makes a lot of sense. So the next one is Vatopi, and Vatopi is also able to make decentralized wastewater treatment systems to remove PFAS and other micropollutants directly at the source. And as you can see also here, it goes in at various points in the cycle in terms of removing the PFAS. Then also here, there is a system from a new plant in Odense. And as you can see, this is also in operation, and a lot of experience here. Then the next one in line is one of the really big suppliers here of complete systems. Kryer is the Danish part of the Veolia group. So Ry is situated in Denmark, and as you can see, the complete group is very, very big. And of course, they are able to handle the complete treatment chain train, and also various solutions, including PFAS destruction. If we just look at some of the highlights here, is that they can take everywhere from the laboratory test to the separation and disposal. So everything in the chain, and here's even more details in terms of what kind of systems that they do supply. And on the first slide, there was your contact. So as you can hear, I'm speeding up because we are a little bit under pressure if we want to have the questions also by the end here to recover some of the lost time. Now we have come to Lumichem, which is basically offering a solution which is a two-stage approach, both in terms of improving the flocculation, in terms of the bulk removal of PFAS, adding proprietary chemistry to secure that you get a good separation in the process, and then also the polishing afterwards, and have access to a lot of different gear and systems in terms of testing out on your actual wastewater whether it works or not, and also proprietary filtration materials. This is how it looks, and as you can see, this is a very effective process also from Lumichem. Next in line is aquaporin. One of the things that we haven't mentioned a lot is reverse osmosis membranes, which is also an effective way of removing PFAS, both in terms of municipal and industrial water treatment, and has been tested both at the University of Aarhus, who's also present here today, and Suez International. And there's consensus in the industry that this is also one of the most reliable ways of physically removing the broad range of different PFAS chains from the water, and it's backed by the EPA in the US. We are moving on here. Another great picture. Now we have Aguarden. I think that was better presented by Jonathan than what I can do, but I can just say that the essence here is that to bring it to the super critical conditions of high temperatures and pressure, under which the organic compounds are broken down in water, by bringing it to these supercritical points. So you separate the water and the CO2 and the inorganic salts from each other from using this innovative process. And a little more here, you can also see this is also a system that is actually working, and both in Denmark and at two sites in France. So again, this is real and live examples. This is not just ideas. This is actually technologies that are out in the field and working. So we have come, and now we've recovered the time, because I do want to have time for some questions here. And I have to say that I do favor now questions from Galliford Try or from the utilities present here today. And I'm just looking down here in terms of some of the questions that have already been. I don't know, Jonathan, did we actually describe at the Corsair case what the flow was? I think you showed it for Yang, but I'm not sure the flow rate was there for the Corsair case.
No, I'm not sure, and I don't know if there is anyone present from Ultra Aqua today that would be able to answer that more specifically than I do. But if there is not, then I know that the water inflow to the plant is controlled by buffer tanks. So I can't remember exactly how much water they take in. They might state it on their website where you can find it, or contact them directly. But they do have buffer tanks that will then be controlled depending on the weather reports. So they will always have water as a buffer, and then they will feed in water to their plant as it comes in. So they always have capacity for whenever the next large rain event will be over the meadow and the firefighting training area. Yes.
Yeah, but I think the right question answer here is that we do know that, because I've been in contact with them and they couldn't be present here today, is that we do know that it functions at quite low flow rates. That's how it's been designed, at least. Just looking at some other questions here. Alexandra Setyukov from Grundfos is asking, I think this was a question for Fabio. Is it an online tool that you were showing when you had the actual data?
Yeah, so I can answer the three questions because they, I think, one for each of the steps or the cases that I presented. So the first one, yes, is an online tool. Is based on monitoring data that have been collected on stormwater runoff from many different surfaces in Denmark. I think it's like more than 100 studies. And the way it works is just you choose a catchment and you define what is the different, let's say, area portion in terms of buildings and roofs, green areas, roads, and also industries. And it would calculate based on historical statistics what's the expected, you can say, concentration of different compounds in the overall runoff. And we are working right now on making it an online, fully, you can say, online tool embedded with GIS, you can say, georeferencing. So we expect to have this by the beginning of this year. On the second step, so that was the initial screening. The plant had the conventional treatment, so a conventional activated sludge and anaerobic digestion. And so when we do this type of studies, we typically will do an initial assessment of, okay, what type of technologies, looking at the market, looking at, for instance, what Klaus has just presented, can help you reducing from the current levels that you have now in the sludge to the required levels by regulation. And then on the GAC, I think that's the regeneration of the GAC is normally done through thermal reactivation. And it's a quite important point because it is very, you can say, CO2 footprint. Reactivating the GAC consumes a lot of energy and also is expected to be a major contributor to the carbon footprint of wastewater treatment plants. And if you look at the wastewater treatment directive, there's also an ambition for the wastewater treatment plants to become carbon neutral and energy neutral, right? So you can say there is a conflicting objective. So it is quite important to optimize the operation of the GAC so that their regeneration is minimized or optimized.
Thank you, Fabio. Then Christopher Prowl has a question. For the FluorFloc PFAS specific polymer, has this been used on the clean water treatment application, or is it just in wastewater?
Yeah, so when you're talking about clean water, you mean like drinking water, for instance, for PFAS removal? Yes, not to my knowledge. And I guess the reason that you don't use it for clean water applications would be that when we're dealing with drinking water, you will already have very low concentrations of PFAS in those types of water. And if you're not able to remove it 100% using the FluorFloc, then it would be better to simply use an adsorbent instead. And when you have very clean water, you then also don't have the same problems with filling your adsorbent with other co-contaminants. So the adsorption is actually already a pretty good solution on its own when dealing with very clean water. So that would be the reason. And then another reason is also that when dealing with coagulation and flocculation technology, it works best if you have a little bit of particles that these things can actually attach to in the water phase, because it's difficult to do a coagulation on a very clean water on its own.
And we have Søren Robenhand. You should all actually, I think, ask the question yourself. You raised your hand. Oh, Sebastian Raun, sorry. Yeah, Sebastian on. Sorry.
I think that's me. It's more a comment on the question actually.
Okay.
So the fluorofloc group, the functional group of that is very similar to that of the ion exchangers that is aiming for PFAS today. So it's a general question. If you want to go very low in PFAS concentrations, it's more efficient to do it with ion exchangers. Also, you don't have the sludge. There's a whole leachage of the ion exchange resin question in itself, but that's, I guess, for another day. It has nothing to do with the PFAS. So in general, what I'm trying to say, if it's clean water, you'd generally aim for ion exchange if you have to compare these two, because the functionality is kind of the same, but the result will be different.
Yeah.
It was a little complex answer, but
Yeah. Thank you for enlightening us. That was good. We have all the experts here. I think Stuart, you also have a question or comment.
Yeah, I think there's some. This would be quite helpful, actually. I think just talking about the additives. So in the UK, we've got quite a lot of surface water processors. So just interested about the additives, and we talked about it because obviously you've got a lot of groundwater sources. So when we're talking about it, you haven't got the other elements in there to provide that. The nucleation thing, for example. But in the UK, it's interesting to look at the use of additives to enhance current existing processes. And the other thing is just more kind of observations. What's quite interesting is at the moment, obviously, we've been looking at in the UK, we're looking at drinking water standards. But looking ahead, obviously, with the divergence from the UK leaving European Union, for example, but where that Europe is heading at the moment in terms of the wastewater standards could be very telling, because it's only going to be a matter of time before that's going to impact in the UK. And it ties on to another observation, really, which is the kind of holistic approach. At the moment, we're going to be treating drinking water, but the use of interventions at hotspots to remove the PFAS from spreading further into the aquifers and spreading further, more of a holistic approach, which is something which is quite interesting as well. It's, we're sort of almost end of pipe at the moment, reacting to the situation rather than saying, well, where is it coming from in the region? Where are those particular sort of industrial hotspots? Could we target that at a lower, using different technology more economically? And it's that bigger picture piece, which I think has been something quite interesting for me today. So there's been a lot to take away, but I thought that really opened my mind really to sort of a wider treatment strategy, really.
Yeah. Very good. Any other questions, comments in terms of what Stuart also just shared?
No, I mean, I think you're absolutely right, Stuart. And I think the approach from the Danish EPA and Danish government in general has been to get most bang for your buck, right? So we only have a limited amount of resources and money to tackle the PFAS problem. So the more we can focus on the most concentrated sources, the better. And then also we know that this has already spread to the environment. So the more we can control it at the sources, the more we can limit it from the circulation. Because it's very difficult to treat very low levels of PFAS in the environment or in our oceans, for instance. It's much easier to catch it at the source, or maybe limit the use in the first place, so we don't have to actually catch it at any sources in the first place. Yeah.
Just a follow-on question. Incineration is used. Obviously, we're talking about a lot of the sewage sludges being incinerated. What sort of reduction, what destruction are you seeing in terms of the PFAS is this kind of domestic sort of municipal incineration processes, or is it specific incineration processes for PFAS-rich sludges?
Yeah, that's a good question, and I think there are many answers to those questions, and maybe some of the audience here will also could maybe chime in. But some of the you could say normal temperatures that you would operate a plant at to incinerate municipal wastewater sludge might not be enough to get a complete removal, where we would say if we get above 1400 degrees centigrade, then you would actually be able to get a complete removal of the PFAS. But it would depend on what kind of temperatures you use and what kind of plant you have. Maybe there is some other audience that will chime in as well.
I think the first question, or whether that is a comment, I don't know, is that Jens Gerle from Grundfos? I think it is. Please go ahead, Jens.
It was a hand and a comment to your question, Stuart, in order to elaborate what is the Grundfos solutions. There are two solutions you see in the deck for municipality, both for groundwater. But the one is purely for the city involved. The second one is to ensure that the pollution is not getting to the water supply for the big Copenhagen part. So there are safety zones, and then they decided, okay, now we are cleaning this up and we are making a protection zone, but why not use the water for the local city in order to just send it to a local recipient? So there are a lot of initiatives away, and the third part where we are very much involved is decentralized to clean up the landfills. With containerized rental solutions, because then we can avoid that it's getting into the bigger circulations. So I think that there are many ways, and all areas should be focused on parallel. Yeah.
Thank you. Thanks, Jens.
I think the next speaker is Søren Eriksen from Krya Veolia.
Yeah, just a comment on the incineration in the Veolia group. There has been quite some testing on hazardous waste incineration, so the high temperature incineration and the suitability of that for destruction of PFAS containing waste, AFFF foam concentrates, and so on, because it is a big topic to go through all the testing to make sure that you are actually achieving destruction, avoiding emissions of products of incomplete combustion. Also a comment about sources. There are also some thermal technologies available for remediating soil. So if you have high concentrations in soils, they can also be treated at some 350 degrees C, typically in piles to avoid the groundwater. So there are different ways of moving back in the system and going for the sources to the extent that they can be identified and delineated and kind of define what has to be treated.
Brilliant. No, thank you. Yeah, I think it's just really opened my eyes. I mean, I think, what the danger is, you end up becoming, you become reactive. There's a standard on drinking water, so you treat drinking water, but you don't think beyond it. You just react to standards as they come in. You're not taking it, thinking more holistically about it. And I think that's been a really major, thing for me, really, from today's meeting, to be honest. It's just opened my eyes a bit more to the wider context, really. But thank you. Yeah.
Thank you. So, Søren Robbenhavn, do you want the last minute? I think you like to challenge this on reverse osmosis, that we didn't have enough attention to that technology.
Well, no, it's just thank you very much, Claus, for giving me a few minutes here. No, I was just wondering why reverse osmosis has not been considered here, as in US it's a common technology used for removing PFAS, and is actually being deployed in a number of waterworks in US. So are there any considerations why reverse osmosis has not been considered here in Denmark, or what are our dear guests from UK thinking about RO as an option?
Should we give, Krya Veolia, Søren, you will get the last chance.
Yeah, it's just that we quite often meet especially when we are looking into landfill leachate, we have this argument that it creates some volume of waste in terms of the concentrate, which is something that can be addressed by evaporating to concentrate it even further. So there's a conception that it's not doing a great job of making a large stream of clean water and a very small stream of waste, but that can be optimized, and we are definitely looking into improving the efficiency of RO solutions, because they're very versatile in terms of addressing multiple contaminants and not only the specific PFAS that you're running after at this time, but it will also be with high degree of certainty be efficient for some of all the other quaternary contaminants that or quaternary contaminants we are looking into in the future.
Yeah, thank you for those answers, and please keep on writing in the chat, sharing knowledge and so forth, because we have to move on to actually follow up and next steps in this learning journey that we are on regarding removal of PFAS. So in a little while, this water talk will end, and Galliford Try and we and Teknologisk Institut and DHI will stay behind and also discuss what we can do next. We have a market visit to the UK, which we are planning for October, and you will learn more on this regarding coming out and being able to share some of the solutions to some of the utilities in the UK together with Galliford Try. We're discussing IWA in Glasgow also in October. We've applied for subsidies there, see if we can make a pavilion of Denmark, but also do something maybe before or after or during together with Galliford Try. And then we've discussed other future water talks regarding other topics that are relevant. And we unfortunately do not have time to discuss what could be relevant, what you think of it. But now you know that this is some of the things that we are thinking of, and you can definitely influence and write me or call me what you think is relevant here in terms of what we should prioritize, because I think it's sure that we will do more together, because I think this today has been great. Then next one. Then here you see the market visit if you want to learn more, also on the IWA in Glasgow. We'll take the last one. And then the next water talk will be on the 21st of January from 1 to 2 o'clock. And this will be about Turkish infrastructure, energy efficiency investments, and EBC. Not that relevant for Galliford Try, but could be relevant for other of the participants of today. Otherwise, I think I'll thank you all. I promised we would finish at the latest at the hour. And I think that is basically it for today. And thank you for all your contributions here and for the sponsorship of Galliford Try, which made it possible. Thank you.
Thank you, everyone.
Thank you.
Thank you.
They're really good, actually.
Thank you, guys.
See you later.
Thanks a lot.
Thanks.
Yes, thank you. That's really good, Klaus. It's really, I think personally, I think we've been so focused on treating drinking water that we've sort of taken our eye off the ball of the bigger picture. I've just got Dave Metcalf, I know personally as well. He's from Ramboll. He's we're going to talk later about, but I think there's a few things in there which really came out. I mean, I think some of the technologies, looking at things from a holistic perspective, the modelling perspective, looking at the catchment-wide solutions, I think is something which I think is just missed at the moment in the UK. I think, your discussion about, we're talking about the holistic, looking about PFAS in sea foams, things like this. I've just not personally heard anyone talk about that in the UK, And I think it's that whole cycle really at the moment, because at the UK at the moment, they tend to put sewage sludge to land.
Yeah.
So, we've got this loop effect of PFAS being removed and then put back on land and re-entering the water supply. And you're wondering how much could be potentially mitigated by, integrating the with the sludge strategies of the water companies, where they put the sludge, what they do to the treatment of the sludge, potentially reducing the overall mass load of PFAS re-entering the cycle.